Let's look at a couple different ways we can get chemical information related to each other and look at the difference between what's called a molecular formula, a structural formula, and an empirical formula. So we've seen several of these things before, but not all of them. So if we look at these two chemicals, acetic acid and methyl formate, we've seen molecular formulas before, and that tells us the number and type of atoms that we have that make up that molecule. So this acetic acid is made out of 2 carbons, 4 hydrogen, and 2 oxygen. So it tells us all the atoms that make up that molecule, but nothing about how they're really connected, right? Because this other chemical compound, methyl formate, has the same molecular formula. It has 2 carbon, 4 hydrogen, and 2 oxygen. And it tells us the number and type of atoms again, but not anything about the way they're connected to make that molecule. So if we look at the structural formula, that gives us a little more information. It actually shows us how those atoms are interconnected. So in acetic acid, we have these 2 carbons sharing electrons and making a covalent bond here. This carbon is connected to 3 hydrogen atoms as well with covalent bonds. This carbon has a double bond with oxygen and a single bond with oxygen, and this oxygen is connected to a hydrogen atom out here. In the methyl formate, we have a little different structure where this oxygen is inside here and the carbon is up there. One thing we haven't talked about before is an empirical formula, which is the smallest ratio of the elements within the molecule. So we have 2 carbon, 4 hydrogen, 2 oxygen. All of those are divisible by 2. So we're saying for every 1 carbon, there's 2 hydrogen and 1 oxygen. And we can see that here for this carbon, there's 2 hydrogen, carbon, 2 hydrogen, and 2 oxygen. So it's the smallest ratio that those elements occur in that molecule. This structural formula has a big impact on the physical properties of a molecule. And when we were talking about covalent bonds, we said that this oxygen-hydrogen ended up being a covalent bond that was a polar covalent bond because this oxygen pulls those electrons within that bond more tightly to itself. So you end up with this bond that has a slightly negative end and a slightly positive end. And that hydrogen bonding occurs between these molecules, and then they will attract to each other much more strongly. So you end up having a higher boiling point because you have greater intermolecular forces because of this bond that you don't have in this other molecule. So one thing that I'll expect you guys to be able to do here is to look at a structural formula like this and then come up with what the molecular formula and the empirical formula are. And all we're going to do to find the molecular formula is count the atoms here, right? So we have 1, 2, 3 carbons, so we'd have C3, we have 1, 2, 3, 4, 5, 6 hydrogen, and we have 1 oxygen. Right, if we come over here, we have 1, 2, 3, 4 carbons, so C4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 10 hydrogen. Right? And so then to come up with the empirical formula, we're going to look to see if there's any number that's divisible here. And this is a 1 here that we just don't draw. So we can't make this any lower. So this would be the molecular formula, and the empirical formula would be the same. If we look at this one, we can divide both of these numbers by 2. So we could have C2H5 as our empirical formula. So this would be our molecular formula, and it would simplify to this empirical formula below. So again, you should be able to look at a structure like this and come up with both the molecular and the empirical formula.